Hi, fifth graders. Tonight's lesson is lesson 10-2, Make Line Plots. The I Can statement is I can organize and display data on a line plot. Press pause and write the lesson number, title, and I Can statement on a new page in your math notebook. When you're finished, press play to continue. Today's solve and share problem is a fifth grade class recorded the height of each student. How could you organize the data? If all the students in the class lay down in a long line, how far would it reach? Make a line plot to solve this problem. I want you to pause the video now to do what the question asks, to create a line plot to solve this problem. When you are finished, press play to continue and see how other people wrote this and help them solve the problem. Okay, so I'm going to reread the problem so I can help to visualize and make a plan to solve this. A fifth grade class recorded the height of each student. How could you organize the data? If all the students in the class lay down in a long line, how far would it reach? So first of all, this question kind of has two steps to it. The first one is asking, how could I organize the data? So the first thing I need to do is create the line plot. After I have all my data organized and created, then I can solve to see if they all lay down, how long the total would be. So my first step is organizing my data. I'm going to, well, that's bad. Okay, so I'm going to create a line plot. Let's see if I can do a better job. Here's my line. The first thing I want to look at is I want to start my line plot with probably the smallest number of data represented. Out of all the numbers I see, it looks like that the number 50 may be the smallest, and I don't see any number higher than 60. So what I want to do now is fill the numbers in between. Between 50 and 60 is 55. Then I'd have 56, 57, 58, 59. And I want to go this way. 51, 52, 53, 54. Okay, I know it's not the most even, but hey, I did my best, right? I also see that there are halves. I know a half is the midpoint between two whole numbers. So on each number, I'm going to place a hash little tag here, a little dash, to represent the half mark. Now, actually, and also too, I better label this so I know what I'm doing. This is the height of students. And I think it's also important that we know that it is to the half inch. Okay, now I need to start doing my plot. So I have the number 55 here. Each number, as I go, helping it or to cross it out helps me know and helps me keep track of what I've measured and what I've collected so far. So I'm going to go through each number. Oh, it's 50 and a half. Oops. Okay, so 50 and a half, be there. Another 50 and a half, 55, another 50 and a half, 50, oops, 55, this, I gotta make that one, 55, another 50 and a half, 55, 58 and a half, 60, 52, 50 and a half, another 50 and a half, 50, 55, 55, 58 and a half. Uh-oh, oh no, why did it do that? I'll put that there's my 50 and a half. And then a 60. Okay, so here is my line plot. I'm going to mark up 60. Now, I plotted it out. I've organized my data of every student and their height. Now, the next question says, if all the students lay down in a long line, how far would it reach? So this makes me think I'm finding the total of all their heights. So what I want to do is I'm going to have to really do a lot of math and adding and some multiplication to figure this out. So the first thing I want to do is I want to add this first row of 50, which I have 2. So 50 times 2 equals 100. My next row is the 50 and a half, which I had 1, 2, 3, 4, 5, 6. So I had 50 and a half times 6. So I know that 6 or 50 times 6 is 300. And then 6 halves, let me do this, 300. And then let me, here, I'm going to have to show you guys how to do this. So okay, let's say it's 50.5 times 6, because remember, 0.5 is half. So I'm going to multiply. 6 times 0 is 0, plus 3 is 3. And then 5 times 6 is 30. Remember, can't forget my decimal. It's one place over from here. I have to move it one place here. So 50 and a half times 6 is 303. Okay. Then I take, oh, why did it do that? There we go. Let me go back to my pen. Then I'm going to count my number of 52s. So then I have 52. I have 52 and a half, and there's 1. My next plot is 55. How many 55s do I have? 1, 2, 3, 4. Oops, here's my 3. 4, 5, 6. 55 times 6. So now I got to do some more multiplication. 55 times 6 equals 5 times 6 is 30. 5 times 6 is 30 plus 3, 330. I have 330. So let me circle that so I know I already did it. Then I have 58 and a half times 2. Again, more math. I'm going to do, whoops. Oh, that's not a good place to do it. Okay, let's do it over here. Sorry. 58 times 2. 8 times 2 is 16. Carry my 1. 5 times 2 is 10 plus 9. 116, and I know a half plus a half is 1 whole. So then that total would be 117. And then the last one is 60 times 2, which is 120. Now, that is how I got the total for each number. Now I have to add all of those together. So I need to figure out a space where I can do that. So let's see here. This is going to get messy. Okay, here's what I'm going to do. I'm going to go ahead and just write 117 and 120 up here so I can erase this to give me some more room. Okay, there we go. Now I'm going to add all my totals. So what? I have 117, 120. I have those. I don't need to do those anymore. Now I'm going to go over here to my numbers. Plus 100, plus 303, 52, plus 52 and a half, plus 330. Now, this is very important. You keep everything lined up. So that way you don't lose track of where you are. So it's my only fraction is a half. So 7 plus 3 is 10. 10 plus 2 is 12. Plus 2 is 14. 1 plus 1 is 2. 2 is 4. 4 plus 5 is 9. 9 plus 5 is 14. 14 plus 3 is 17. My 1 and 1, 2, 3, 4 plus 3 is 7. 7 plus 3 is 10. So my number, my answer would be that it is 1,074 and a half inches. That would be the total. Wow, that's a lot of work, but so worth it. Anyway, let's go see how other people solved it. This is Emily's work. Emily did something pretty similar to me. She set up her line plot. It asks, how does Emily use the line plot to answer the question? She finds the total length for the students of each height and then adds them together. That's exactly what we did. Hers is a lot nicer and neater, but I wanted to show all my work so you could see how each dot represents a student and then how you take each one of those measurements to add it together to get the total. You don't do that for every line plot. We were just solving the question that this problem was particularly asking. Next, we had Tyler's work. Tyler did his differently. He did his in a frequency table. As you can see, first he wrote down each one of the measurements in this column, and then he used tally marks for students instead of using a line plot. He used tally marks to mark how many students were of each one of those measurements, and then he wrote the numerical total. Now, what error did he make? You can see here that he got 326 inches long total. What I'm thinking he did is that he added all the numbers right here in this column, but he wasn't considering the fact that there were several students who were the same heights that he didn't account for. So after you've seen my work and you've seen the other two students' work, think about your work. I want you to write a summary in your notebook about how you organize the data, how you set it up, how you thought maybe it was the easiest way to solve. Maybe it was different, maybe it was the same. I hope you didn't give up because this was a problem that took a lot of thought and a lot of process and patience to solve. So I really do hope you took the time to solve it and to think how to collect the data, how it's represented, and how you could use it to solve the problem as a whole. This is where math is really fun. It just takes a lot of perseverance to push through to get these problems solved. I'll be excited to hear about your thinking and hear your summaries tomorrow. Good night.